Hi everybody. Just thought I'd give you a brief rundown on the topic of message forwarding, or what I like to term semi-automatic proxy delegation. Proxy is an element that represents another element. So for example, a proxy vote is a slip that's sent to a central authority in lieu of appearing. Now I'll just mail my vote in. I don't need to go to the voting polls. And so people will use that slip as though I were there, and they'll count the vote rather than going in person. The proxy delegate is a simple interface to a complex system. In other words, they'll say something like, well, check here next to your favorite candidate, and then just mail it in. And whatever is going on in the background, I don't need to know it. I just have a simple interface to proxy vote. The bridge pattern, that's what happens when you have a client with a simple interface, and that server implements the interface, and we use the interface to communicate between the client and the server. And so what we want is a transparent distribution of the application. And this is a key element in simplifying the use of remote method invocation. With message forwarding, what we're doing is we're taking the message and passing it from one place, let's say the client computer, to another place, the server. In an object-oriented programming message forwarding system, we do a method invocation and forward the method invocation to another instance. So for example, here's a class called Mammal, and it has some property that says has hair is true. Here's another class called Movable, and it has a property that says you can move things. Now what would happen if you had a movable mammal? Right? This is multiple inheritance of implementation. You'd like to be able to get the property of has hair, and you'd also like it to be able to move. Well, to do that, you would have an instance of the movable and an instance of the mammal, both in the composite relationship between movable mammals. So movable mammal is a class that has a instance of movable and an instance of mammal in it. Then what happens when you invoke the move is you message forward m.move to the movable, and you forward movable mammal has hair and to the mammal has hair, and return that property. So you don't exactly have inheritance here. What you have is composition. So the proxy uses an implementation of another class. I don't want to rewrite mammal. I don't want to rewrite movable. So I create a new proxy class known as the movable mammal. And so that is the delegator, movable mammal, whereas mammal and movable, they are the delegatee. And so this is an interesting relationship, right? Because it's has a. For example, Professor Lyon is a human, but Professor Lyon has a pen. The relationship between is a and has a are completely different. Here, the proxy uses an instance like mammal and movable, and so it has a relationship of using these instances, and therefore this is composition. So then there's this notion about static proxy delegation. And in this case, what we have is method invocations that are checked at compile time. So we want the compiler to do some of the work, which means we have to generate the code for the compiler to look at. And so we have source code generation facilities that will add methods to the delegatees and then forward those methods to the composed relationship instances contained by the delegatee. So dynamic delegation is somewhat different. These are new methods in the delegatee that automatically appear and are available in the proxy at runtime. This is a feature for JDK 1.3. It's not typically type safe. It can throw exceptions. For example, you can use reflection to invoke a string on an instance. When you have a string that you're invoking on an instance, if your string is misspelled, it's going to throw an exception. Semi-automatic static delegation is compile time checking for type safety. It's synthesizing new classes with source code. The delegatee changes are discovered using introspection and cause a resynthesis of the proxy, and then you process the Java source code synthesis at a pre-processing time, that is by the compiler. So you have a new time. There's the design time, where you input an instance into the synthesizer, a generate time, where you output proxy code to a file, a compile time, where you compile the new proxy, a link time, where you dynamically link to the proxy and the classes that use it, and then finally we have a runtime, where we invoke the method in the proxy. So then the question becomes, well, why do semi-automatic static proxy delegation? And the answer is you can get a better interface to a complex system. It enables code reuse. You don't have to change the existing code or the legacy code. And it's easier than manual message forwarding. It's type safe, has easier to maintain properties, and it's an alternative to inheritance. You're doing the buildup of a composite class using composition. So why not just use multiple inheritance? Well, we don't have multiple inheritance of implementation in Java, only multiple inheritance of specification, which we get by multiply inheriting interfaces. It's less reliable to have multiple inheritance. Duplicate methods with the same signature tend to shadow one another, and therefore you must do some form of disambiguation, such as topological sorting. Shadowing is decided at compile time, which means if you rearrange the inheritance order, the behavior will change for multiple inheritance. And topological sorting is not something that is going to be easy to debug. If you change the order of inheritance and then the behavior changes, you will find that you have a fruitful source of bugs. So here's an example of multiple inheritance confusion. Suppose somebody said, oh, I like cosine. It's a very nice trig function, but I also like degrees and I don't like radians. So here's the trig rad, and we don't know if cosine is radians or degrees. Math.cos, no doubt, is in radians. The compiler doesn't care. That's a semantic issue. You put in something like 90 degrees into math.cos, it'll assume you mean 90 radians. It'll give you an answer. It's just not the answer you expect. Here's another example where we do the invocation, and now we convert from degrees into radians. Well, that's not something a lot of people might expect. They expect cosine to be used in radians. But if you like degrees, you can convert everything to degrees and then convert it to radians when you need math.cos. So now suppose you have trig rad, that's in radians, and trig degrees, which is in degrees. And so now you've extended both of these things with multiple inheritance. How do I know which cosine is going to be invoked? In Zeta Lisp or Smalltalk or C++, you can do this. You can have multiple inheritance, but not in Java. Even Simula permits it. So this ambiguity exists when you have a topological sorting multiple inheritance system. Here's another example called diamond inheritance. Here the base class is a subclass of input stream and output stream. So the stream is extended by input stream and extended by output stream. Now I want an I/O stream, input and output stream. So I inherit both input stream and output stream to create the iOS stream. This diamond inheritance is very common in C++, but it has all the problems of multiple inheritance, leads to a complex linking stage, gives you tons of overhead because each instance will grow, and most of the overhead is in the memory allocation, which means every time you do a new, and the memory has to come off the heap, and this creates what's known as the fragile base class or constant recompilation problem. You change the superclass, and all of the subclasses have to be recompiled. So what's good about diamond inheritance? I get to add features just by subclassing. I can make a single large class, and I can create toolkits. And so now you have a brief overview of dynamic and static delegation and the difference between Java's form of inheritance and multiple inheritance. Thank you.